Hello and welcome to day 24 of my Advent of Code series for 2020. If you've missed any of the previous episodes, you want to check those out, check out the playlist linked right up here, and let's jump into lobby layout. So we've gotten to our hotel and we need to help because the lobby floor is being renovated, so we can't really get to the check-in desk. So pretty much how it works is the tiles are all hexagonal and they need to be arranged in a hex grid with a very specific color pattern of having white and black tiles. So as our input, we are given instructions here. And each line of these instructions is mapping to one tile, and each instruction is telling us to flip that tile. So the instructions are composed of directions of east, southeast, southwest, west, northwest, and northeast, and there are no delimiters between them. So we need to figure out what tiles these are. They all go from the same central reference point. And we need to go ahead and figure out how many tiles are going to be black at the end if they all start as being white. So this one is very doable. I highly recommend you go ahead and give it a try, and let's jump into my code right now. So the first thing that I do is I establish our actual grid system. So when you're doing a hexagonal grid, the trick here is your actual direct east and west you want to multiply by 2, and then everything else works exactly as you would expect in a normal grid system. So that's just establishing our directions. So then for all of our data, I go ahead and I split each line, and I pretty much am trying to break down each line into a list of instructions. So how I do that is for each thing, I go ahead and establish a cur, which is just the current instruction, which is going to be an empty string. And on every single character, I check if cur plus I is in directions.keys, so if it's a valid direction, essentially. And if so, I put it into our instructions array, and then I reset cur. And if it's not, then I go ahead and just set cur to be it. So that it not being valid is only going to happen on north and south, which, as you see, those both need to capture the next token after them to become a valid instruction. So then once we do that, we will generate all of our paths, and and that is it. So then our actual part 1 here is just going to be returning the length of init board, where init board is going to return a set of all of the black tiles at the end of our initialization here. So what we do is I loop through every single path. On every single path, I initialize our coordinates that we're looking at as 0, 0, and then for them, I loop through each instruction. I go ahead and I grab the directions for that instruction. So I grab the actual mapping that we're going to get, so the actual integer values. I loop through the length of coordinates here, and I just go ahead and add 2 coordinates. This is just doing a piecewise addition between our coordinates and our actual directions, the direction that we get. So that's going to move our coordinate by however many. Then I turn it into a tuple so that it can be hashed, so we can put it in a set. If it is not in the set, then I add it to the set, and if it is in the set, then I remove it from the set. So then at that end of that, we just go ahead and return the set, and for part 1, we just need the length of that, and that gives us our answer. So then we can jump into part 2, which is yet another Game of Life clone. So I've tried to keep the code slightly different so that you have something different from the last 2 Game of Life clones that we've already had this year. So pretty much it's Game of Life. We need to do it 100 times, and the rules are any black tile with 0 or more than 2 black tiles immediately adjacent to it is flipped to white, and any white tile with exactly 2 black tiles immediately adjacent to it is flipped to black. So there, it's just talking about the ones that are 1 move away from each tile, essentially. And rules are applied simultaneously, just like in any Game of Life, and we need to say how many tiles are going to be black after 100 runs through of that loop. So I highly recommend you go ahead and give this a try, and we'll jump into my code right now. So for part 2, we grab our initial board by using that init board function, and then 100 times, what I do here is every time I initialize a dictionary called neighbored. So this is going to include in it every single tile that gets touched, essentially. And what we're doing here is I go ahead and loop through every single tile that was black before. If it's not in neighbored, I go ahead and initialize it in neighbored as 0, because that will simplify the loop that we're doing later. I don't have to check 2 separate sets. I only need to check 1 set. And then what we do is I go ahead and loop through every single direction. For each of those directions, what I'm essentially doing here is I establish cur, which is just going to be the coordinates as being whatever our tile is that was black before. So this is just a way to generate every single tile that is next to another black tile. I go ahead and modify that, turn it back into a tuple, and then from there I go ahead and check if that's in neighbor.keys. If it's not, then I go ahead and initialize it as 1, and if it is, I just go ahead and add 1 to its value. So this is just a way to slowly get the number of times that each tile is neighbored. So then what I do is I initialize a set called new black, which is what our set of black is going to look like at the end of this step. Then I go ahead and loop through every single tile in neighbored. So neighbored is going to contain every single tile that has any neighbors at all, or any tiles that were black last time, even if they have no neighbors. And what I do is I just go ahead and check either if the tile was in black before, so that means it's black, so we need to check if it has either 1 or 2 neighbors, then it's going to stay black. But if it wasn't black before, so if it was white before, then if it has exactly 2 neighbors, it's going to flip to black. So in either of those conditions, we go ahead and add that tile into our new black set. And then finally, we set black to be new black. And then once that loop runs through 100 times, we just go ahead and return the length of black, and that gives us our answer. So that is going to be it today. Be sure to stay tuned tomorrow for the finale of this series. And if I helped you, be sure to leave a like, get subscribed to me so you don't miss any of my future videos, and I will see you next time. Goodbye.